Alright, in this video we will be answering how do we graph exponential functions. Remember, exponential functions look like this. First, let's talk about exponential growth versus exponential decay. Exponential growth rises from left to right, whereas exponential decay falls. Now, exponential growth, this b that's being raised to the power of x will be greater than 1, whereas for decay it'll be some number between 0 and 1. Both the parent functions for growth and decay have horizontal asymptotes at y equals 0. Exponential functions follow the same rules as all the other parent functions. We recall that this a out here is a vertical stretch or compression based on what a is, and if it's negative we would reflect it over the x-axis. H and k do what they've always done. This is a left and right, and this is my up and down. K also shifts the horizontal asymptote. One last thing to note is that if you had a b to the negative x, this would be a reflection over the y-axis. Now to graph we only need 2 points. Okay, what we do is we find the points 0a, 1ab, then we apply the transformations. For this example, a equals 1 because there's nothing out in front of the b. b is the base of the exponent, if you didn't learn that last year. So the points I have for 0a, 1ab are 0, 1, and 1, 2. Now I need to shift these right 1 and up 1. To shift right 1, we just add 1 to the x values. And then to shift up 1, we're going to add 1 to the y values. So my new points are 1, 2, and 2, 3. Notice that because k is positive 1, we have a horizontal asymptote at y equals 1. So that'll be the very first thing I plot, my horizontal asymptote. Now I'm going to plot those points, 1, 2, and 2, 3. And then it's exponential growth since b is greater than 1, so I start from the left and rise through these points. And that's the graph of f of x is 2 to the x minus 1 plus 1. Alright, so let's look at 2 times 4 to the negative x plus 1. The first thing I'm going to need are my 0a and 1ab. So I've got 0, 2, and 1, 8 for 2 times 4. Alright, next we see that this plus 1 means up 1, so I'm going to add 1 to the y values. And finally, because of this negative right here, that's a reflection over the y-axis. And over the y, we do that last. So that just switches my, my x-coordinates. So 0 is not going to change, but this 1 will become a negative 1, 9. So whenever I graph it, I'll have the points negative 1, 9, 0, 3, and my horizontal asymptote got shifted up to y equals 1. And so with these exponential graphs, sometimes we'll be dealing with lines without numbers. As long as we label our points and our asymptote, we're fine. Now there's also another way of looking at this problem. We could have looked at this as f of x equals 2 times 4 to the negative 1 to the x plus 1. And that would just be 2 times 1/4 to the x plus 1. And here we have exponential decay because this b is between 0 and 1. Well, doesn't this graph look like decay? It is. And we can actually find another point right inside of here. Doing the 0a, 1ab, we have 0, 2, 1, 1/2. And shifting the y's up 1, we now have 0, 3, 1, 3/2. And look at this graph from Desmos. We have the negative 1, 9 that we saw earlier, and the 0, 3, and also we have the point 1, 1.5, or 3 over 2. So again, if you have this negative here, you can pull the exponent away from the x. But you have to remember, if you're doing that, to pull the negative out from everything. So this would be 3 to the negative 1 to the x minus 2. And exponent properties say that this is okay because negative 1 times x minus 2 is negative x plus 2. I like dealing with things this way because in this way I never have to worry about reflecting over the y-axis. And that also gets us ready for e, the natural base. This is the base of a natural log, right? And you saw this last year, but you have to remember e is a number. And whenever you do that, you'll understand that e to some positive number would give me growth, whereas e to a negative would be decay. And this should make sense because, like, think about e squared. That would be this number squared, which would definitely be bigger than 1. Whereas, like, e to the negative 1 is the same thing as 1 over e. 1 over e is not going to be negative, but it is going to give me a number between 0 and 1. So let's look at y equals 2 times e to the negative x plus 1 minus 2. The first thing that I want to do is rewrite this as 2 times e to the negative 1 times x minus 1, notice the sign change, minus 2. So this is going to be stretched by 2, moved down 2, it's going to be decay, and it'll be shifted right 1. A lot of things going on in this graph. So first let's find 0a, 1ab. That'd be 0, 2, 1, 2 times e to the negative 1 is 2 over e. Or you can just leave it as 2e to the negative 1. Because at this point, we're going to go to our calculator and figure out what this is. All right, and we get 0 to 1.735. And this is what we would expect. We would want the number further to the right to be lower than this starting point because it's decay. All right, so next we see that each of the points move left 1, so I minus 1 from the x's, and they move down 2, so I'm subtracting 2 from the y's. All right, so my final 2 points are going to be negative 1, 0, and 0, negative 1.26. And this is going to have a horizontal asymptote at y equals negative 2 because it was shifted down 2. So let's graph it. I'm going to plot a horizontal asymptote. I'm going to call this y equals negative 2. And then I'm going to plot the points negative 1, 0, and 0, negative 1.26. Draw the curve that falls through them because it's decay. And there we have it. This is our graph right here. Here, take a second and take a stab at it, and then compare it with mine in just a moment. All right, we should have ended up with the points 0, 4, and 1, 10.4. Its growth and the horizontal asymptote went up 3. All right, that's your review of graphing exponential functions. Goodbye.